So we're going to look at acceleration due to gravity and free fall one more day of this, right? And I want to talk about this problem. Michael Jordan, okay, who's a famous basketball player, played for the Chicago Bulls, right? His best vertical jump was 1.17 meters, which is pretty high, okay? And what we want to calculate today is how long was he in the air? And we're going to neglect air resistance, okay? On all of these problems, we're going to neglect air resistance. Okay, so what are some things that we know about this, right? So one of the things that we should realize is when he reaches the top, when he reaches this 1.17 meters, which is the top of this, right here, we should realize that his velocity at that moment in time is 0 meters per second. Okay, so this would be the floor or the court down here. All right. And so since he's starting there, that's going to be my starting position, y sub 0. And I'm going to want that to be 0 meters. So we're measuring this 1.17 meters from the floor, right? So that means going up is going to be positive and going down is going to be negative. So that means this high position right here, okay, when he reaches the highest, that's going to be my final position for this velocity. So I'm going to label that one y. And I also know that y is going to be this 1.17 meters. Okay, so everything that I know, and what I'm going to do is how long was he in the air? I'm going to figure out the time that it took to go up and reach the highest point. And then all I need to do is double it and get that would be the time going up and down. Okay. So what we're doing in this first method, we're going to actually do this problem two different ways, okay? We're going to find the time going up. And hold on a second because I'm going to pause and I'm going to go get a better pen because I'm running out of ink on this one. Okay, so I'm trying to find t. But that t, you have to realize that's the time that it takes to go up and reach a velocity of 0. Okay, so for that time, I know some things that I know is that v sub 0, the starting velocity, I'm sorry, not the starting velocity, whoops, the final velocity, right, is going to be 0 meters per second. I know my starting position is down here on the floor, so that's going to be 0 meters. And I know my final position is going to be 1.17 meters. And the other thing that we should realize is that there's acceleration due to gravity. That's called g. And we know it's negative 9.8 meters per second squared. So we look up here and which equation deals with all of this and t, right? And what we should realize is it's this one right here. All right, because I have y sub 0, I have the final velocity, which is going to be 0, I have g, and I'm going to be able to use this to find the t, okay? So we have y is equal to y sub 0 plus vt minus 1/2 gt squared. Okay, so are any of these 0? Well, yeah, this one's 0. And my v is 0. So both of these are going to drop out. And what I have left is y is equal to negative 1/2 gt squared. So to clear out my fraction right here, I'm going to multiply both sides of this equation because I'm trying to get to t. I'm going to multiply both sides by -2. So I get -2y is equal to gt squared. So that means -2y divided by g would equal t squared. And so t would simply be the square root of -2y over g. So t is going to wind up being, for our problem, t is going to wind up being the square root of -2 times y, so times 1.17 meters, over g, which is the negative 9.8 meters per second squared. And I'm going to grab my calculator. And I'm going to put this in. Okay, so first I need the square root, so second square root, then I need the fraction bar, so alpha x, and then -2, and then parenthesis 1.17, close the parenthesis, and then the denominator is -9.8, and press enter, and we get 0.49 roughly, right? So I want it around to two significant figures, so this would be 0.49 seconds. Now, for the time in the air, we're going to have to double that because this is only the time going up. Okay, so the time in the air, we would calculate by doubling that. So 2 times 0.49, which would give us 0.98 seconds. So that's pretty close to 1 second. Michael Jordan was in the air for 1 second, which is kind of a long time to be in the air, right? Somebody said once that he had the best hang time of any NBA player. I don't know if that's true or not, but somebody said that one time. Okay, so Jordan was in the air for 0.98 seconds. All right, so that's one way of solving this problem. I'm going to do this another way because some of you may see, but Mr. Mitchell, I could have done it this way. So I want to give you options so you're aware of other ways you could attack this problem and solve it, okay? So same exact problem, okay? But up here, we recognize again that the velocity when he reaches the top is 0 meters per second. Again, down here, we're going to measure from the ground floor, the floor of the court, right? And that's going to be my starting position. And it's going to be 0 meters. And going up is going to be positive, and going down is going to be negative. And so this height right here, when he reaches this velocity of 0, that's going to be his y, and it's going to be 1.17. So the way I'm going to do it this time is we're going to find the initial velocity. And once I find the initial velocity and I know the final velocity, which I know the final velocity is 0 right here, right? And I know G, I could use this equation to calculate the time. All right, so I'm going to use this to get the time, but to get time, I got to first figure out what the starting velocity is, okay? Or the initial velocity. So I'm still trying, so this time I'm going to find V sub 0. And what's known is that my y sub 0 is 0 meters. My y, my final position when he reaches the 0 meters per second is 1.17 meters. And I know V is equal to 0 meters per second. And then I also know that G is negative 9.8 meters per second squared. So to get V sub 0, what I'm going to first use is this equation right here. Okay, so I'm going to use V squared is equal to V sub 0 squared plus 2G times Y minus Y sub 0. Are any of these 0? Yeah, this one's 0, and my Y sub 0 is 0. So this one's going to be, I'm going to write this one as 0 equals V sub 0 squared, and then plus 2G. This Y sub 0 is 0, so that's just going to be times Y. Okay, so to get Y, I'm going to move the 2GY over to the other side, and we get negative 2G times Y is equal to V sub 0 squared. And then to get Y by itself, I'm just going to divide both sides by this negative 2G, and I get Y is equal to, I'm sorry, I'm solving for V sub 0. Hold on. I forgot what I was solving for. Okay, so I need to square root both sides, right? And so if I square root both sides, all right, that's going to give me the square root of negative 2G times Y is equal to v sub 0. So that's my v sub 0. My v sub 0 is the square root of negative 2g times y. So calculating that, I now know that's the square root of negative 2 times negative 9.8 meters per second squared times y, which is the 1.17 meters. And extend my square root. And putting this into the calculator, I first press square root, then negative 2, and then parenthesis, and then negative 9.8, close the parenthesis, and then another parenthesis, 1.17, close the parenthesis. And we get 4.78 or 4.79, and that would be meters per second. Okay, so now I know the final velocity, I know the starting velocity, and I know gravity, so I could use this to figure out the time, and this would still be the time going up, all right? So in this case, I'm gonna use a different color, okay? I'm gonna find the time going up. And so that's going to be, I'm going to be finding t. And what I know is that v is 0 meters per second. And I know v sub 0 now from this up here is 4.79 meters per second. And I know g is equal to negative 9.8 meters per second squared. And I'm going to now use this equation to figure it out. Okay, so v is equal to v sub 0 plus gt. That means v minus v sub 0 is equal to gt, which means v minus v sub 0 over g would have to equal t. So to get my time, I'm going to have to take the final velocity, 0 meters per second, subtract the initial velocity, which is 4.79 meters per second, and divide that by negative 9.8 meters per second squared. And if I put that into my calculator, I wind up with 0.49 seconds. And once again, I would have to double it because this is only the time going up. I would double it, and then I would have the time going, the total time Jordan was in the air. So again, Jordan was in the air. For 0.49 seconds. So I do this, all right? So Jordan was in the air for 0.49, not 0.49, sorry, 0.98. That is not correct, right? So 0.98, because I have to double it. So once, and I doubled it on the last page, that's why I'm just writing 0.98, all right? So once again, okay, this isn't the most efficient way of solving it, all right, but it is another way to solve it. So maybe some of you see it like I could do this, I could get that, and then use that to get something else. By all means, you can do that, okay? It just, this particular problem, it takes a little bit longer if you do it this way, okay? All right, so let's do a couple more problems and we'll be done. Okay, so for this problem, all right, we have a rock that's thrown upward with a velocity of 30 meters per second from a cliff 120 meters above the ground. How long will it take the rock to hit the ground? So this rock is going to go up and then down past the cliff. So we cannot do time up equals time down on this because it's going to go further down than where it started. So we have a cliff. I'm going to draw my cliff. We should be, okay, on your papers, we should be drawing a cliff too, okay? So it's going to be thrown upwards. So it's going to go upwards and then it's going to come down and it's going to hit the ground right here. Okay. So right here where it hits the ground, okay, I want that. I want to measure from that. So that's going to be 0 meters. So that's where I'm going to measure from. Okay. So this is going to be my Y. This is going to be my Y sub 0. and I know I'm starting a cliff and it's 120 meters above the ground. So I know my starting y sub 0 is going to be 120 meters above the ground. That's where I'm starting, and I'm going to end at 0. Okay, so I want to know how long will it take the rock to hit the ground. So I'm finding t. Okay, now what do I know? Well, it was thrown upwards, right? So that's going to be a starting velocity that's positive. So thrown upward is v is positive. And it's going to be positive 30 meters per second. So I know v sub 0 is equal to 30 meters per second. And I know my y is 0 meters, and I know my y sub 0 is 120 meters. And I know my a, or in this case, gravity, g, is equal to negative 9.8 meters per second squared. Right? These are all the things that I know from the problem, okay? Now, which equation can I use? Well, to find time, okay, I really can't use this one to find time because I don't know the final velocity when it's hitting the ground. I also can't use this one because I don't know the final velocity when it's hitting the ground. This one doesn't even have time. This one deals with the final velocity, and I'm given the initial velocity. So the only one I can use is this one right here. Okay, so we have y is equal to y sub 0 plus v sub 0 t plus 1/2 gt squared. Okay, so is anything 0? Yeah, the y is 0. So this is going to be 0, and that's the only thing that's 0, right? So this is going to be 0 is equal to y sub 0 plus v sub 0 t plus 1/2 gt squared. So we have everything in this equation but t. And what we should be recognizing is that this is a quadratic, right? Because we have a constant here, we're going to have a number here, we're going to have t, and we're going to have t squared. So this is a quadratic, and that's why I have up here the quadratic formula. Okay. So I don't try to solve for t, because that's it. That's how we're going to solve. We're going to use this quadratic formula. Okay. So what I know is that 0 is equal to y sub 0, and y sub 0 is 120 meters. And then plus my starting velocity, 30 meters per second, times t, and then plus 1/2 times g, which is negative 9.8 meters per second squared, and then times t squared. Okay, cleaning this up, and I'm gonna, for the sake of doing the quadratic formula, I'm gonna leave off the units here. So this is gonna be 120. This is 30t, so plus 30t. I do want to take half of negative 9.8, so that'd be minus, right? Because I'm multiplying a positive times a negative, so I'm going to write minus 4.9 t squared. So if we move everything to the other side, we get 4, and you wouldn't have to do this, okay? So we have 4.9 t squared minus 30t minus 120 equals 0. In this case, for the quadratic formula, we have it in the form in which we can use the quadratic formula. So this is our a value. This is our b value. So it's going to be negative 30, and this one is going to be our c. So we instead of x, because our variable is t, we're going to have t is equal to negative b, so that'd be positive 30, plus or minus the square root of, and it'd be b, which is negative 30 squared. And you'd have to put parentheses around your negative number when you square it here. And then minus 4 times our a, which is 4.9, times our c, which is negative 120. So I notice on the test that a lot of you guys use positive 120 when it should have been negative 120 for your c value. All over, okay, and then 2 times our a, which is 2 times 4.9. Okay, so there's 2 answers to this, right? So we're going to do the fraction bar first, and then 30, and then plus, and then square root. And then we need to put parentheses around the negative 30. And it needs to be negative, not subtract. And then we need to square it. And then minus 4 times our A, which is 4.9, times our C, which is negative 120, all over 2 times 4.9. Press enter, and we get 8.9 or 8.88 seconds. So T is 8.88 seconds. Okay, so another possible answer is we could copy this, and then instead of the plus, we need to type in minus, because this is plus and minus. And we get negative 2.76. But that one doesn't make sense, because that would mean this happened, okay, negative 2.76 seconds before I even threw it upwards. So this one doesn't make any sense, okay? Because I started time 0 right when I released the rock here, okay? So how long did it take to reach the ground? It took 8.88 seconds, okay? So the rock took 8.88 seconds to reach the ground. And let me slide that up. And so the rock took 8.88 seconds to reach the ground. All right, one more problem that I want to do with you guys. And that has to do with a fighter jet from Lemoore. Okay. All right, for this problem, we have a fighter jet from Lemoore Naval Air Station vertically climbing. So vertically means it's going up and down, but it's climbing, so that means it's climbing up. It's going upwards, all right, at 295 meters per second. So this right here, this vertically climbing, tells you the velocity is positive, and it's at 295 meters per second. And then at a height of 950 meters, a part of the plane breaks off, okay? And so neglecting air resistance, how long will it take for the part to hit the ground? Now, what's going to happen is, because that part is part of the plane and the plane is going up, that part is actually going to continue upwards for a while until gravity takes over and starts, well, as soon as it comes off the plane, gravity's taking over, and it's going to go up for a time, and then it's going to come back down. All right. So I'm going to draw a plane here the best that I can. All right. So here's the plane going up. All right. Here's the wing. All right. And it's going up, and a little part breaks off. Right. And it's going to go up. It's going to continue to go up. And then at some point, it's going to come back down, and it's going to hit the ground. Right. All right. And so how long did it take for it to hit the ground? Right. Okay, so what are some things that we know? Well, ground level, this height of, well, let's start with this. We want to find the time, right? So we want to find T. All right. And then I want to also know, what is the velocity at the start? Well, we know that the velocity at the start is this 295 meters per second. So V sub 0 is 295 meters per second. Now, the ground here, right? This height is measured from the ground. So this needs to be 0 meters, all right? And that's the final position. So that's going to be my Y. So my Y is equal to 0 meters. Right here, okay, is the starting position, right? And so that means this was at a height of 950 meters. That's when this part broke off. So this Y sub 0, the starting height, is 950 meters. So Y sub 0 is equal to 950 meters. And the only other thing that I know is the acceleration, because it's due to gravity on this part, and it's negative 9.8 meters per second squared. So I'm trying to find T. All right, and this one won't do me any good, because I don't know the final velocity. I don't know the velocity when it's hitting the ground. Okay, if I did, then this would be good. All right, I could find the final velocity if I use this. Okay, and then I could use this for the time, and that would be fine if you did it that way. But there is a faster way, right? Because if we look at this one, this has everything that we have here, all four things, right? We have y, we have y sub 0, we have v sub 0, and we have g. We could use this, and what's going to want you need to realize, okay, that's going to give us a quadratic formula when we're trying to find time, though. Okay, so we have y is equal to y sub 0 plus v sub 0 t plus 1/2 gt squared. So I know the only thing that's 0 is going to be this one. And I know y sub 0 is 950 meters. And then plus, and I know my starting velocity is the 295 meters per second times t. So I have a t and a t squared in this equation. And so then plus 1/2 times negative 9.8 meters per second squared. And I'm running out of room. And then this would be t squared. Okay, so this, I'm going to, without the units and multiply and clean this up a little bit, this is going to be 0 is equal to 950 plus 295 t. This is going to be minus 4.9 t squared, because half of negative 9.8 is negative 4.9. So that's why we're writing the minus 4.9. So we could also, I know I moved last problem, I moved everything over, but I could also write this as negative 4.9 t squared plus 295 t plus 950 equals 0. If you like moving everything over, that's fine. You can do it that way. All right, so this is your A. This positive 295 is going to be your B, and the positive 950 is going to be your C. And again, our variable is t. So t is going to equal negative of b. So that'd be negative 295 plus or minus the square root of b squared. I'm just using this, okay? So b, which is 295, so I'm going to put parentheses around it. 295 squared minus 4 times my a. In this case, my a is negative 4.9 times your c, which is 950. And that's all over 2 times a, which is negative 4.9. So putting this into our calculator, fraction bar, and then negative 295, and then plus the square root, and then parentheses 295 squared. Slide that up a little bit. And then minus 4 times, and the a is negative 4. So we don't want to use a minus, we want to use negative 4.9. Close the parenthesis, and then open a parenthesis, and then 950 over, and then 2 times negative 4.9. 2 times. And again, we don't want to use the minus, we want to use a negative 4.9. Press enter, we get negative, for that one, we get negative 3.06 seconds, which that answer is not going to make sense. So we're going to cross that one out, because that means it landed prior to it coming off the plane, right? So the other possible answer is to come up here, copy it, right? And then come over here, and instead of the plus, we're going to retype, and we're going to type minus. So that one's subtraction, not negative, okay? And press enter, and this time we get negative, or 63.26, and I said round to 3 decimal places, right? 3 significant figures. So this would be 63.3 seconds. So that's how long it would take. This thing would be in free fall for 63.3 seconds, neglecting air resistance before it hit the ground. Okay, so the part took 63.3 seconds to reach the ground. Okay, and that's how you solve these problems. Okay, so today's a little bit different because we're using the quadratic formula.